So we're dealing with surface area and volume. So we're gonna start off with surface area. And these are just some of the areas we just took a look at. You don't have to write them down. You should already have them. These are the areas. This is the area of a trapezium, a half the sum of the parallel sides times the perpendicular height. I believe that I did put out a challenge for somebody to prove this. Was anybody able to prove it? It was a challenge, you know. The challenge was you have a trapezium, and these are the parallel sides here. We'll call it A and B, and this is the perpendicular height, H, and the area of a trapezium is a half the sum of the parallel sides, A plus B, multiplied by that perpendicular height, H. Right? Imagine this is A and this is B, and you have this being H. So imagine if I was to cut it here, and then I cut it here. Right? Remember, this will be H and this will be H, right? So I will put these two together. So I'll literally cut out this triangle here, and I'll cut out this triangle here. So all I'll be left with is the rectangle in the middle. So if I cut out that triangle there, and I bring it and I put it here. Oh, well, that don't work. Yeah. Let's just say, I thought I could have moved it, right? Let's just say we have the two triangles here. This is one, and then we take this one because these are both H, right? So we take Zafir. We take this one and put it over here. Right? Now this is not how they had cut up the triangles last time. This is not how they cut up the triangles. Well, not last time, but Sharice, in your video, they didn't cut the triangles like this. And this is kind of like an easier way, because the area of the trapezium would be the area of this rectangle. Remember, if this side is A, then this side will also be E. From here to here will also be E. So the area of that rectangle is A times H plus the area of, well, I hope you're paying attention as Zafir, right? Please tell your cousin that you're in a class, right? The area of this rectangle here. Well, what is it? Well, we know the area, the height is H. This length here, right? Remember, this whole thing was B, right? This whole thing is B. And what we did was we minus this section. So we minus A. This section here is the A, right? Let me write the A in a different place. A, right? So then we have these two here to form the base of the triangle. So this was the B, the full B, minus the A. And so you have the area now being the area of the rectangle plus the area of this triangle, which is a half the base being B minus A times that perpendicular height H. Now, this is where I'm gonna leave it. I'm gonna leave it right there. I'm not going to go forward, right? You see that the area of a trapezium is the area of a rectangle plus the area of a triangle. You are supposed to boil this down like Baji using algebra, of course, algebraic Baji, right? And you are supposed to get a half A plus B times H. When you simplify this, this is what you're supposed to get. That will be for next class. So I asked you guys to prove this last class, and here I am giving you most of the proof. But let me just see how your algebra will work out when it comes to going from here, right, going down the line. Alright, so I want to actually go through the lines. You can see they both have H in common, so maybe that could become a factor later on. But what you should do is you should expand this out totally and then see if anything could minus, and maybe you'll end up with this, right? So anyways, let's start this. So see if you guys can get from there to there for the next class. The next class will be our questions class, where we will be answering questions, right? Today we're dealing with surface area. And for surface area, you had to know the area of all of them things. You have to know the areas of all of these things that we were talking about here. Forget about this one. Imagine if you take this piece here and you cut it like that, right? So let's just say that piece is this one here. Oh, I think I see how they looking at it now, right? Then you have this side here, and then you have this side here. That'll be your two sides here and here. So these numbers are kind of wonky, right? Kind of confusing. It's really just a matter of imagination. Then you have this here, which I thought would have been that number 3. Or they have it the other way around from how I'm looking at it. So you have this there. You could think about that as being, yeah, this here is, you can think about that as being this here, right? And that would make, I'm gonna go with other colors, but you all getting the point. You all getting the point. That would make this front face here number 6. That being this front face over here. So you have to be able to take a 3D shape, break it down into its net, and find the area of each part. And that is what surface area is about. And yes, surface area is a question that you are going to get. Let me take a look at another surface area example. Right? This one might be a little bit easier since we're dealing with a triangular prism here. Right? So you could easily see that this is the number 3 indeed. This base here. So that base is the number 3. You have to imagine how it would be like to cut up this box. You would have to find the area of this triangle. You would have to find the area of this triangle. So you have to find the areas of these. And then of course you have this backside, which we will call 5 over here. And then you have this front side, which is 2, which is the slant side, which is this one. And so you could see in a shape like this, right? And I hope that you guys are actually drawing these prisms, right? You should be drawing these things, yeah, or at least sketching it to see what it looks like, right? But with these things, you will see that you had to find the area of this rectangle, this rectangle, this rectangle, and then you have 2 triangles here that you have to find the area of. So surface area is about seeing the box and breaking it up into the net of the box and finding the areas of all of the different shapes. And so you could see how you have to know all of your area formulas. You had to know your area of a triangle. You had to know your area of a rectangle. This one is obviously one of the ones that you get often. And let me ask you all a question. You can see I have the answer underneath the screen there. But if you're finding the surface area of this, right, you'll have to find the area of this circle here. So that is the area of a circle. Then you had to find the area of this circle here, which is the area of another circle. So you had to find the area of two circles, right? But how do you find the area of this curved surface over here? The curved surface that's going all the way around. How do you find the area of that? If you cut it here, excellent job. If you cut, and thank you very much, Cherise. Because of you, we can get on with the class a little bit quicker. But if you cut it there and you roll it out, what you're actually gonna get is a rectangle, right? And this is where we had cut it. We had cut it here, and we had cut it here. Right? So what you're actually gonna get is a rectangle. So when finding the area for this thing, the area for this circle going to be pi r squared. The area for this circle gonna be pi r squared. But what's the area for the rectangle going to be? The area for the rectangle is going to be the base multiply by the height. But what is the base of the rectangle? This is a question that does always come for CSEC, and kids does always get their head teeth with this. But remember, this rectangle gonna wrap around. It's like, I have a perfect example here. So imagine this is the rectangle and you're wrapping it around like that. And so you have the two circles, one on the top, one on the underneath. You have the circle there, right? You know, and you can find the area of that circle, the area of that circle. Then when you cut this now and you unravel it, look at what the length of the base is. The length of the base is actually the circumference of the circle, because it's the entire rectangle have to wrap around the circle. So that circumference of the circle, when you open it out, is what forms the length of that base. So this base here will actually be 2 pi r, which is the circumference of the circle.
Circumference of the circle would be on the edge with the circle.
Yeah. So the circumference of the circle will be this edge here. And?
Yeah.
Right.
So it will be side with the circle attached on it in the rectangle.
No. This is just kind of how, well, I guess yeah. If you look at it that way, but no, it wouldn't be. It wouldn't be. Though I get what you're saying, but the diagram not really. You know what you saying is this. What you saying is that this will be the height. That is what you're saying, and
Yeah.
and this will be the base. But I'm pretty sure that this here can wrap around that circle. Yeah, I'm pretty sure. Right? So this diagram here is not like drawn like how, you know, like this circle is at the top and this circle is at the underneath. You don't have to see it like that, but sure, you can see it like that if you want to. I just cut this here vertically, and so I made the vertical cut here. Right? And then when you spread it open, if this is H, this B will be 2 pi r. However, if you had it like what Cherise was saying, where you have this as H and you have this as the base, you'll get the same answer. Yeah, as long as you recognize that one side of the triangle is what's going to be, and what Cherise is saying is that it should have been drawn like this. This is what Cherise is saying. It should have been drawn like this. You have this, and then you have one circle here, and one circle here. Yeah, that's what Cherise is saying. So you can draw it like this if you want. So here now, I know that we ain't do no formulas yet. We ain't studying nothing special yet. What I'm showing you is what surface area is about. You are going to be given a three-dimensional object, and you have to find the area of each side of the object. And what is usually happen is a student might find the area of all of the sides of the object, but they could forget to do the underneath, or they could forget to do one side. So in order for you to get this right, you had to be able to know how to split up these normal objects. You have this first one here being a cuboid or a normal box. You have this one here being a prism or one of them Toblerone chocolate boxes. And then you have this one being a cylinder or one of those Smarties cylinders or Pringles. And that is essentially what's going on with surface area. We do have the surface area of other weird stuff. Yeah? Like the surface area of a sphere, for example. And you should write this down in your cheat sheet. Is 4 pi r squared. That is, no problem, Samaya. That is the surface area of a sphere. Now, hardly anybody will remember the surface area of a sphere. I guarantee you that CSEC is not going to ask you for the surface area of a sphere. If CSEC is doing a surface area question, it'll be one of these that they're going to give you. You better pray that they give you this one. They might give you this one, but they like to bring this one. Yeah, they like to bring that one. So with surface area now, you know, they're not going to bring the surface area of a sphere, so don't hurt your head too much. However, if they do bring the surface area of a sphere, most of the time they will actually give you the formula in the question itself. So any of these out of the way kind of shapes, right, they'll give you the formula for it. They expect you to remember your normal formulas: parallelogram, triangle, trapezium, them formulas we had in the cheat sheet. That is what they want you to remember. They'll understand that you can't remember this, no problem. They'll include it in the formula sheet or even in the question. But please make a note of it because it is on the curriculum. Yeah. So please make a note of it, the surface area of a sphere. This is also on the curriculum. I have never seen it in an exam. However, if they do bring it in an exam, chances are they will give you this formula here. And this is the formula for the surface area of a cone. And the formula for the surface area of a cone is pi r squared. You could tell that is the surface area of the circle underneath, plus pi r l. L is the slant height, right? Where L is the slant height, not the perpendicular height. And you can see the difference here. You can see that they do have the perpendicular height in the shape here. This is the radius of the base circle, but this here is the slant height L. So you're actually using this slant height. It'll be interesting trying to prove this one, yeah, but thankfully I like stuff like this and stuff like this, because you see how, you know, you could prove the surface area of a cylinder, right? The surface area of a cylinder is the area of the two circles. So the surface area of a cylinder, we could make up our own formula for it, is what I'm saying. we could make up our own formula. And of course, you don't have to go and remember this formula, but I'm just showing you, is the area of two circles. So that is 2 multiplied by pi r squared plus the area of this here, which is 2 pi r times h. Yeah, and so this, I could call this my very complicated looking formula for a cylinder. Sure, I could call it that, but we smarter than that. We know we don't need to learn this. It's really just finding the formula of a circle, another circle, and then a rectangle, but knowing that the length or the base of the rectangle is the circumference of them circles to wrap around the circle. So surface area and even volume is all about seeing these shapes. Imagine trying to prove the surface area of a sphere. Imagine proving this, the surface area of a sphere, because a sphere is something that you cannot flatten. If you have an old basketball, do me a favor, take that old basketball and try cutting it up so that it will lie flat. You will see that it is impossible. You cannot cut a sphere anyhow for it to lie flat. So imagine how they come up with this. Yeah, they came up with this actually something to do with volume, but that is beyond you guys. You guys don't have to prove these things. You guys just have to know how to prove the basic things, but not these things, right? So as I say, the surface area of a cone is this ugly looking thing here, but you do not have to worry about committing it to memory. Most likely, if they ever bring this in an exam for you, it'll probably just be they'll probably give you the actual thing, the actual formula, right? They'll give you the formula if they ever bring it, right? So if I want the area of this thing, the surface area, the total surface area, right? So that is what I want. I want total surface area. Right? What would that be? Well, first, I would have to find the area of this circle here as the base circle, right? And then I'll have to find the area of this circle here. These two circles are the same. So I could find the area of one and then multiply it by 2. Yeah. So the area of the circle is 2. No, not 2. What wrong with me, boy? Pi r squared, which is 3.14 times r, which is not 20. R would be a half of 20. Let me rub off all of this stuff. R would be a half of 20, which is 10. So that is 10 squared. So that is 3.14 times 100. 12, which is 314 centimeters squared. No, not centimeters, sorry. It's in meters, isn't it? So 314 meters squared. This is the area of one circle, right? So the area of two circles, the area of two circles will be the 314 meters squared times 2. Where is my calculator? Okay. So that'll be 314 times 2, which is 628. So 628 meters squared. So that is the area of both of these circles here. Alright, the area of one circle is 314, and since the other circle is the same thing, I just multiply that by 2 to give me the area of both circles being 628. Now we have to find the area of this side here that going all the way around. And what we were saying is that if we was to cut it down and then spread it out. So we cut it there and we spread it out. What we get is a rectangle. The height of the rectangle is 13 meters, and the base of the rectangle will be, remember this rectangle is wrapping around the circle. So this piece here is wrapping around the circle. So this piece will be the circumference of the circle, which is 2 pi times the radius, which is 10. Radius is 10, not 20. 20 is the diameter, right? So what do we have here now? We have the area of this part being the base, which is 2 pi times 10, multiplied by the height, which is 13. So 2 pi is 3.14 times 2 times 10 is 62.8 multiplied by 13. That gives us just a 62.8 times 13. What did you guys get for 62.8 times 13? Can somebody do that for me?
816.4.
Okay, 816.4, and this will be meters squared, of course, right? So this 816.4 that you gave me, Amir, I could see that you did the surface area of the surrounding rectangle correctly, but like you forgot to add the surface areas of the two circles. So the total surface area would be the area of the rectangle plus the area of the two circles, which is the area of the rectangle is 816.4. This is what Amir gave us his answer. So you could tell that he made a little bit of a mistake. He forgot about the two circles. That's fine. The reason, remember, you guys are not here to be right. You're not here to be right at all. You know, you're here to make these kind of mistakes. That's why you are here. Yeah. So we have the area of these two circles being 628. And so the total will be, where's the total there? Where's it work out to be? This is actually the final answer. I have this here, right? And let me just say that is this one, where this side is 10 and this side is 20, right? But I have another one just like it at the bottom over here. This one over here. So I have two of these. So this area will be times 2, right? So I have 2 of these. All right, no problem. So I have 2 of those. Then I have this one on the side here. So that will be this one here. And I can see that, well, this is the same as this. where the length is 10 and the height is 7. So you see, it's just about breaking it down. And you see how you have 2 of them? So whatever the area of this is, I'll just multiply it by 2 to get the area for the 2 of them. Then I have this side one here. And I'll draw that side one, looking like this. And you can see that I have a base of 20 and a height of 7. And guess what? This one here will be the same thing. So this one here is also by 2. So the total surface area will be, let's call this shape 1. Let's call this shape 2, and let's call this shape number 3. So shape number 1, the area of shape number 1 will be the base times the height, which is 10 times 20. And then I'll multiply that by 2 because it's 2 of them. It's 2 shapes. Then I have the area of number 2, which is 10 times 7, and I'll also multiply that by 2 because it's also 2 shapes. Then I have the area of this one, which is 20 times 7, and I'll also multiply that by 2 because it's 2 shapes. So you see what's going on here? That this is really just the area of a whole bunch of rectangles. So it's not to say it's hard to find the area of this stuff. No, it's just rectangles. The problem is that the rectangles form a box. So you had to make sure that you could see all of the sides of the box. So I tackled this one here is the top and the bottom of the box. This one here is the sides of the short sides of the box. And this one here is the long sides of the box. Alright, so this is shape number 1. This is shape number 2. And this is shape number 3. So now what do we get? We get 10 times 20 times 2 is 400 here. Plus 10 times 7 times 2 is 140 over here. Plus 20 times 7 times 2 is 280 over here. And when I add those up together, I get 820 meters squared.
Good afternoon, sir.
Hey, Sabina.
Evening, sir.
Welcome. I'm glad you could make it early. I was expecting you later. We're doing surface area right now, and these children not representing at all, well, except Cherise. So congratulations to Cherise. Cherise, you conquered it. Good job, right? Zafir, do you understand what went on here? Right. Well, I will be calling you all just now. So that was surface area. Right. Now, first, we had started off with perimeter, right? And perimeter was just the distance around. So you take this distance and add it to this distance, blah, blah, blah. And you add it all up. All right, A plus B plus C plus D plus E. And you'll get your answer in centimeters or meters or whatever. So area is the distance, per perimeter is the distance around. Then we talked about area. And by extension, surface area. And area, well, that had to do with how much space does the shape occupy. Right? How much space is it taking up? And so you have your breadth times your height, breadth multiplied by height, and this is how we get centimeters multiplied by centimeters. This is how we get centimeters squared. Now we are talking about volume. With volume, we are talking about a 3D object. Think about like a tank, and I'm drawing a very crude water tank here. So we have a crude water tank. Imagine you fill this water tank with water, right? So you have water, fill the water tank, and well, in this case it's not totally filled, right? But you have water filling up the water tank. How much water will go in this water tank? So we want to find out how much space is inside the object now. The inside of the object, that is what we're talking about volume. And in order to find that, you have to take the area of the base. So the area of the base will be what? You know, you have length times breadth to find the area of the base, and then you have to multiply it by the height. So to find volume, you're taking the area of the base, whatever it is, and you're multiplying it by the height. That means you're taking your units and multiplying them 3 times. And that is why the units for volume is cubed. So whenever you're giving your answers in volume, whatever your units is, whether it's meters or centimeters or liters, it'll be cubed. So we are met with the volume of our first shape. And please write this down over here. For the volume of any shape with a uniform cross section. Uniform cross section means if I was to take a samurai sword and cut it here, slash, and I cut this whole thing in half, what will I get? I will get this here. It'll cut so, and this shape here, which is the cross section, is the same as the base. Yeah. So no matter where I cut this thing, no matter where I cut it, the cross section will always be the same as the base. Even on top, you know, once you have that cut being the same as the base right through, that is a uniform cross section. Right? Once you have an object with a uniform cross section, and chances are this is the kind of object you will get for exam, all you have to do is find the area of the base. No matter what the object is, find the area of the base and multiply it by the height. In this case, we have a cube. So it just so happens that with a cube, all of the sides, the area of the base and the height are all the same. And so you'll get a cubed. But really and truly, I don't want you to think about it like this. For any cuboid, you'll have the length times the breadth times the height. I want you to think about it like this. Volume is equal to the area of the base times the height. So that'll be length times breadth times height. Any questions? I have some questions for you. Anybody still writing here? Another example here. This example is of a cuboid. Right? And remember, for the volume of any shape, you just, once it have a uniform cross section, you can see here, this is what the base looks like. The base is a 10 by 10 square. And if I was to cut this in half, this cross section here gonna be a 10 by 10 square. No matter where I cut it, that cross section gonna be a 10 by 10 square. So this has a uniform cross section. So answers in the chat right now, right? So remember, for anything with a uniform cross section, the volume being how much water gonna fill up this whole thing. If you throw water inside this tank, how much water is going to be inside of the tank. So how do we find that? You just find the area of the base, which is 10 times 10, and you multiply it by your height times your height, 35, right? So that is, right, the length times the breadth times the height. The area of the base times the height. 10 tens are 100 multiplied by 35, which is 3,500 centimeters cubed. It will be cubed. Right? Very close, Addy, right? I didn't, let me just leave this for 30 seconds in case anybody's still writing. For this question that we did just now, I didn't move and go. All right, so we have the volume of a cross-sectional shape. But look, I have the volume of this. This is another cross-sectional shape, right? And I was supposed to say that this here is a right angle triangle. Right, so the base here is a right angle triangle. Yeah. Find the volume of this. The volume of this. This is a uniform cross-sectional shape. The volume of this. Answers in the chat. It should only take a minute. Answers in the chat, please, from everybody. All right. So when it comes to finding the volume of anything with a uniform cross-section, you can see that if I was to cut this at any point, I will still end up getting this triangle. So that means it has a uniform cross-section. So that means I just have to find the area of the base. So the volume is the area of the base multiplied by the height. So the area of that base, it's a right angle triangle. So it's a half base times height multiplied by this other height. Right? So a half, the area of this triangle is what I'm looking for here now. A half base, well, we'll call the base 12 and we'll call the height 10. You could really call anyone because multiplication is commutative. Then you're multiplying it by the 25, which is this height over here. The height. Naima? Naima, you're pouring your microphone by mistake, young lady. Alright? Careful with that. Alright? It does sound like you have a lot of distractions around, though. Interesting. So you'll see here, what do I end up getting? I end up getting a half of 12 times 10 is 120 multiplied by 25. A half of 120 is what? 60 multiplied by 25. 60 times 25 is 1500. Actually, Sabira, all of them 1500 people was correct. 1500 centimeters cubed. What is the volume of this cross-sectional shape here? volume. This is not surface area, volume. So remember, the volume of anything with a uniform cross section will be the area of the base multiplied by the height. And this is a uniform cross section because if I was to cut it here, you will see a circle same as the base, or no matter where I cut it, the circle will be the same as the base. So it's uniform cross section. But just remember that the base in this case is a circle. So what is the area of a circle? The area of a circle is pi r squared. And then of course you had to multiply it by the height. So the area of the base is pi, which is 3.14. Pi is always 3.14. Pi is a constant. So pi is always 3.14. Multiply by r, the radius. The radius is not 6. Yeah. Isaiah, I have a feeling you use the radius as 6. But the radius is not 6. The diameter is 6. The radius will be half of the diameter. The radius is 3. Yeah? So you have the radius being 3 squared multiplied by the height, which is 15. So that'll be what? 3.14 times 9 times 15 is 423.9, and this answer will vary depending on what you used as pi. Yeah? Wait, that is true. Any questions on this? Now that is essentially volume, That is essentially volume. You know, the volumes that you will get in your exam should be the volumes of objects that have uniform cross section. And when they have a uniform cross section, you just find the area of the base and multiply it by the height, and you will get the volume. Yeah. But we do have other volumes on the curriculum that we should know about. This one here being the volume of a sphere, right, or a ball. So the volume of a sphere is 4/3 pi r cubed, where pi is 3.14. CSEC will understand if you can remember this. It is on the curriculum though, so you should probably put it on your cheat sheet maybe. But you know, if CSEC ever gives you this question to find the volume of a sphere, most likely they will actually give you the formula with it. They will not expect you to remember that formula, right? So there's the formula for a sphere. Then you have the volume of a cone. So the volume of a cone is 1/3 pi r squared h. Yeah, 1/3 pi r squared h, where h is the perpendicular height. Yeah, so make sure you make a note of that. H is the perpendicular height. This is another one that you will not really have to remember for CSEC. However, the questions that I am going to give you will require you to have it. So the questions that you're going to get from me will require you to have it, will require you to use it, right? But for CSEC, if they ever give you this, chances are they will give you the formula with it, right? And they will give you the formula for a pyramid as well. In terms of the volume of a pyramid, is the area of the base times the perpendicular height divided by 3. Yeah, that is the area of a pyramid. Probably don't even need to write down this one. Sorry, not the area, sorry, the volume of, and this is a square-based pyramid. Or, I think it should work for any pyramid, honestly. Yeah. The volume of a pyramid is equal to the area of the base multiplied by the perpendicular height, all divided by 3. So we could rewrite that if this was length and this was breadth. We could rewrite that as length times breadth times perpendicular height divided by 3. That will give you the volume of a pyramid. And yes, the base of the pyramid can be a rectangle, a triangle, a square, or even a pentagon. It will work once you find the area of the base, multiply it by the perpendicular height divided by 3. Right? That is the volume of a pyramid. And we have our volume questions here. So you will get 2 volume questions to do right now, and that will be the end of it. 2 volume questions to do right now, and let's take these 2, number 5 and number 6. So number 5 and number 6, find the volume of these objects. This unit here is inches, in case you're wondering. It's a uniform cross section, so it's just the area of the base. So the volume is the area of the base times the height, and this is the height here. So the height is 3. The area of the base is pi r. No sense of humor, yeah? Pi r squared times 3. Remember, you see here, they didn't give you r. They give you the diameter is 4. So r will be half of 4, which is 2. Yeah, so pi times 2 squared times 3. So 2 2s are 4, 4 3s are 12. 12 times 3.14 works out to be about 37.68 inches cubed. Plenty earlier given me it in centimeters. Earlier, lucky and not taken out for units, right? And let's look at this one. Well, oh gosh, this one is easy. This one is a cuboid. You have the area of the base. So let's call this the base. Right? And then this will be the height. Yeah. So the area of the base is 2 times 2. And then multiply by the height is 2. 2 2s are 4, 2s are 8 meters